Our team has been asked to submit a design for a new city in the Democratic Republic of Congo, located near Lake Tumba. We have planned for an initial population of at least 25,000 people and growth up to 100,000 people. This is intended to be a showcase project that will highlight the state of art in smart, sustainable urban planning that we have created. Here we have a final physical design of our city. The first layer of our city would be the districts. We have an industrial, commercial, and residential district. The industrial district is similar to the name. It is the industrial side of the city, is where companies and etc. factories will be located, and also where our hydroelectric plant will be created. So the industrial area is closest to the river on the side and closest to Lake Tumba on the other side. So it can harness the water power and the utilities that the water can provide. We also have a small commercial area in between industrial and residential. The commercial area is small because we realized we didn't need a very big one, but in the commercial area lies our main city, which is accessible to both the industrial and residential area. And the residential area is by far the biggest, open to more expansion, and also farthest away from both bodies of water, so with also a higher level above the sea to prevent flooding, or to decrease the amount of flooding that would happen. And on the legend on the side, you can see other individual specialties that have been added into the physical design of the city that will be discussed more in depth later into the presentation. And also on the Orange Road, we have a road connecting to another local city further upstream in the river for ease of access and trading, and also more accessibility for the city to grow in more ways than just the land that's provided for us to use. The city will be bike-friendly in addition to providing public transportation in the form of buses. The city's road designs would be displayed in French. 3 tiers of roads will be implemented into the city. On a local level, the smallest and slowest roads would be paved with gravel. For an area prone to rain and flooding, gravel provides improved draining and better upkeep. These local roads will have 2 lanes for residential access. The next level, collector roads, will transport residents up and around the local area. They will have fewer homes and will be bigger and faster than the local roads. These roads will be paved with asphalt. We plan to use roundabouts for high traffic areas. The third tier of roads will be regional arterial roads. These will be the biggest and fastest roads in the city and will be paved with asphalt. There will be no traffic lights on these roads, and they will serve to connect with other cities and roadways. Like American highways, they will have no stop signs, only ramps. The Congo River is one of the deepest and longest rivers in the world, and so the Democratic Republic of Congo has vast untapped potential for hydropower. To harness this power for the proposed city, our team would strengthen existing hydroelectric infrastructure, such as Inga 1 and 2, as we harness solar energy. These projects would not only power the city, but provide access to electricity throughout the region. Our city would require around 500 watts of electricity to function, and if properly restored, the Inga project would supply a maximum of 1,400 watts. The city would get its water from Lake Tumba, which would be purified and fluorinated in a modern water purification plant. Lake Tumba also provides an opportunity to build a server farm and bring internet to the region. There will be two ways of removing waste from the city. Solid waste will be stored in a landfill south of the city and separated from the river. Its placement in this location will separate it from both the city and the river while not needlessly increasing transportation costs. The trees around it will prevent flooding, and local wind patterns will push any airborne pollution into an uninhabited area. Sewage will be piped to a water treatment plant on the southwest part of the city. Here, any water can be cleaned and will be put back into the Congo River, and any solid waste will be added to the landfill. The residential space will be laid out as such. Look to the map for guidance. Although the residential area can fit in about 1 square mile for spacing purposes, we decided to start the residential space at 10 to 15 square miles. The residential area will start near an arterial road to increase people's access to all parts of the city. Housing districts will revolve around a centered urban area where there will be restaurants, local stores, etc., and schools. The residential area will also have access to the main city in the commercial area through a central arterial road. Residential needs to fit population requirements, there will be 2 K through 6th grade schools and 1 7th through 12th grade schools, with each a 2,000 to 3,000 person capacity. Next, we will be starting with 1 hospital, 5 to 7 beds per 1,000 people, with a capacity of 30 to 40 open beds. This will be located by the residential area on the central arterial road. To maintain crime and emergencies, 1 large combined fire station and police station will be located also on an arterial road for easy city access. Additionally, parks will be added to increase property value and make the city look less dismal. Important details to maintain a good residential area are hospitals, education, a fire and police station, and added bonuses so that the city may be able to take care of itself, which we have included in all these people needs. This housing design we've created is to be implemented in the residential area, and we plan to have everyone in the population living in. The design. For the residential population, we created a double-leveled unit housing. This is 4 houses connected on a central corner to make a unit. Each house is about 1,000 square feet, about a city loft size, and about 7 feet tall. Each unit will have a second level for residents both above and below. We will use recycled wood collected from clearing the initial city area to build these units. A deck area will be added to each house and can be used as a cooking space with proper ventilation. Roofs are built to deflect heavy rainfall. Housing units are built on stilts and/or hills about 2 to 3 feet tall using recycled tires packed into the dirt. Water will pool around the base of the hill rather than reaching the housing units. A water system and/or water will be brought to the community through cheap, durable plastic piping systems, and additional solar water heating systems will be added for heating and cooling of water. Multiple windows would be added for ventilation for hot days, and cheap fiberglass insulation will be installed for cold nights. Bathrooms will be connected to a sewage system, and electricity will be provided from the hydroelectric dam. Finally, flood protection includes the stilted housing, raised electric units, interior-exterior backflow pipes, a shielding roof, and people are able to take refuge in top levels if lower levels are flooded. As the population grows, the city will expand down towards the residential area, away from all bodies of water, decreasing the chance of flooding the city. The complex housing system is able to serve multiple purposes if needed, such as supporting municipal and commercial buildings. If the residential people were to move to a different area, buildings could be used for, say, a company or something like that, where unit housing would be easily transitional into a different building. As the population GDP grows, citizen housing will evolve towards singular housing further away from the lake and river to gain more protection from flooding. The use of environmentally friendly resources to power the city will help maintain a good city environment as it expands, so city environments won't lose infrastructure and turn into slums. The dam's hydroelectric power and resources will be much easier and cheaper to distribute and maintain as the city grows. With research, planning, and ingenuity, our group has designed a fresh new city to improve pre-existing conditions in the Dominican Republic of Congo, as well as offers new bountiful opportunities to the people that live there. So join Tumbaville today. Thank you for listening to this presentation.